What if I said, hey kids, go find g of 0 when you stuff in zeros right there?
Yeah.
So go find g of h of x. Would you take h of x and place it in there?
Yeah.
Okay? Or think of the eraser game. Okay, it's just the eraser game. We haven't played the eraser game, have we? It's a new game. The eraser game. The only difference between g of x and g of h of x is that I'm going to erase the x and put h of x in its place, right? I'm going to erase the x and erase the x, put h of x in there, and you get cosine of what?
H of x.
Cosine of h of x plus
E to the h of x.
e to the h of x, sure. Okay, we're thinking abstract today. Okay? We're not doing concrete math, we're doing abstract stuff. All right? And that would be g of h of x. That's nothing fancy. That is called the substitution property for middle school. Remember that one? Substitution property. The stuff it property. Okay? Stuff it in there. All right? So, there it is right there. Okay? All right, that's all fine and dandy. Now, number 5. Can you write an expression for h of g of x? Okay? Let's take g of x now, right? Take g of x and stuff it into the, gee, I don't have an h of x here, do I? All right? There is no h of x. It's unknown. You can't stuff it in here, all right? You can kind of stuff it over here, and you can do it that way, but I prefer not to instead. All right, so that would be a big fat no. Okay? And now, on the test, upcoming, you will have a decision to make. You will have to choose, do I use g of h of x or h of g of x? And one of them you can't stuff anywhere, so you're going to say, I'm not using that one. And the other one, you can substitute it in, you'll say, I'm going to use that one. Okay? So make a choice on the test, not this one, that one. Okay? All right, now let's go to number 6, lowercase Roman numeral 6. All right? Which states, find the derivative h prime of x. Okay? I got some issues with this one. Okay? I have some concerns. Some major concerns. All right? Now look over here. We can't even find h of x. How are you supposed to take the derivative of a function that you don't even know? Okay? Well, we've got a little bit of math trickery coming out here. Because you actually can do the derivative of something that you don't know. All right? Here's how we're going to do it. Okay. First of all, I need to write a master equation. There's that. That's right. That is our daily bell, kids. That was all planned. Okay. 4, let's do a little master equation business here. Okay. So, here's what we have. Do you notice that in number 4 and number 2, those are both g of h of x? Everybody see that right there? Okay, they're both g of h of x. One of these equals x. That's because the inverses cancel each other out, right? One of those was just done by substitution for middle school. Now, according to the blank property, if a equals b and b equals c,
Transitive.
then a equals c by the transitive.
I didn't even know that was a
All
It
right.
is plus 10.
All right.
Kirsten or Stephanie Roberts.
Wow. Plus 20.
Okay. Very nice. Well done. So the transitive property says if this equals that and that equals something, then this equals something. So what you can do is fuse them together, drop out the middleman, and just say these two are equal to each other. You need a master equation. So, did we not just show that cosine of h of x plus e to the h of x is equal to x? Didn't we just show that?
Sure.
And is it not true that you can go through here and take the derivative to get the derivative world? Okay? And is it not true, Your Honor, that the derivative of cosine is
Negative sign.
negative sine, and the base always
Stays
stays the same, but the most important rule in mathematics is the chain rule, and the chain of h of x is h prime of x, and the derivative of e to the h of x is keep it the same,
ln
natural log of
the base
e, which is 1,
times
chain rule is
h
h prime of x, and the derivative of x is
1.
aha.
So let's factor out that much better.
Now, you know what this is like? It's like what we just did in the last test called what? We did something just like this.
Oh.
But it had y's instead of h's.
Right sign?
Yeah, it was that
Oh, yeah.
implicit derivative section, right? Yep, that's it. It's like an implicit derivative. Okay? But you have h primes instead of y primes. Alright? So, all you have to do is get h prime by itself, and you will have the derivative of a function that we don't even know. How about that? And that's clever right there. Okay? And all we did was make a master equation based off of these two. By the way, 3 and 5 are dead ends because you know this one, but you don't know that one. Okay? So that didn't help, that didn't help.
So do you factor out any?
Okay? So, to isolate h prime all by itself, if you have two of those, we should factor to the front. Negative sign of h of x plus e to the h of x equals 1. And all you have to do to get h prime by itself now is divide both sides by all that jazz. Okay. And then you put it over here. You can actually just drop the parentheses on the last h of x, or you can keep it, doesn't matter. All right? And voila, you have the derivative of an unknown function. Right there. Now it is in terms of h of x. By the way, it said right there on the page, in terms of h of x, what does that mean? That means it's okay to leave h of x in your answer. You don't have to change it to something else. We don't even know what it is anyway. It also means, it gives you the reassurance that you should have h of x in your answer. Okay? By the way, see this equals 1 part right here? That was a little piece of guess what? Rule
Number 2.
number 2. Here's what you didn't see off the behind the scenes here, because you don't have to write this. But weren't these two actually equal to g of h of x? Okay. So this was g of h of x equals all that. You don't have to put that. And then when we did the composite derivative, isn't this g prime of h of x times chain rule h prime of x?
Sure.
Okay. So that's what you don't see off the screen here. But look at this. Take this and that. Isn't that rule number 1 right there? We're on the air. All right. Isn't that rule number 1? And isn't this rule number 2 right here? Close. Where's that one that landed all the way down, somehow magically staying stuck in my pants all the way to the very bottom? But how's that possible? All right. So that's part of rule number 1, rule number 2. There you go.